In this section, we're going to be talking about more types of graphs, some different ones than we covered in the last section. And we also need to talk about something called continuous data and discrete data. Now, there's a difference, and some graphs are better suited to different types of data. The Some of the other graphs that we've seen already, we didn't talk about this in those terms, but we're going to talk about it now when we see line graphs and scatter plots. So line graphs are great for continuous data. Now, what that means is literally what it says. The data continues. It's all in the name. For instance, someone's height. If you were to measure a child's height as they were growing up, like every year on their birthday, let's say that one year they were 4 foot 2 inches, and the next year on their birthday they were 4 foot 5 inches. Well, somewhere in between those two dates, they had to be 4.3 inches, or I'm sorry, 4 foot 3 inches, or 4 foot 3 3/4 inches. Somewhere along that there's that continuum that continues going. They're not just 4 foot 2 and then the next day wake up and be 4 foot 5. They actually had to grow. So at some point in between those two dates, they were every single number on the number line in between those two values. So that's what continuous data is. Now, discrete data is something where you're talking only about specific values. So, for that, let's look at the scatter plot so you can see that. This scatter plot here is talking about quiz score results. So we have very specific values. This hour studied, somebody who studied 1 hour made a 1 on their quiz. Somebody who studied 2 hours made a 2 on their quiz, and so on and so forth. There's not really any values in between these two, so that makes that more discrete. Okay, now back to line graphs. I said that they were great for continuous data. This is what a line graph looks like, and this is plotting someone's weight over their first 9 years of life. And so you can see that, at date zero, so when they were born, they were under 10 pounds, so probably about 8 pounds something. And then on their first birthday they were just under 20 pounds. Well, somewhere in between those birthdays they gained, pound by pound by pound. So eventually all of the numbers on the number line are covered in between there. That's what makes that continuous data. And then we can draw a line in between each one of those points to represent that data. Okay, scatter plots. Scatter plots are another type of graph that we'll be talking about and seeing, and you guys should have covered this in college algebra also. But scatter plots are where we actually plot individual data points on an X and a Y axis system, and then by doing that, we can find the line of best fit that would give us kind of a trend. So it's also called trend lines that would show us how these things are related to each other, how the hours studied are related to the quiz scores. So we can get a general idea that if you study more, your scores should be higher on the quiz. That should be kind of self-evident, but it's nice to be able to see that mathematically in a trend line. Now, trend lines and scatter plots, there are three different types. We have those that these have an association, meaning the plots are clustered close together. And you can see that when we draw in that trend line, it's going from left to right up. That means that it has a positive slope in the trend line. Now remember, lines are all come in the form of y equals mx plus b. In this form, it would be y equals mx plus b. Remember that m is the slope of the line, and so it would be positive in this case because we're going from left to right up. In this case, again, you can see that all of our plots are closely scattered together, so we can draw a trend line through that. But in this case, our slope would be negative, so that would be a negative mx plus b. And then here's an example of a scatter plot where there's no association whatsoever. Everything is just scattered completely willy-nilly. So you really can't draw a trend line and get good data off of something that looks like this. Now, it's also possible to graph several lines on the same graph and then compare those two things. Like, for instance, here we have a graph that's talking about the population of 5 different states. So it's always important to have your legend out to the side so that you can read your graph and see what it's talking about. So here we have our red line is talking about Florida. And so we can see that in 1900 we had, well, not very many people in here, way, way, way less than 2,500. And then it continues to go up in population year after year after year. And again, this would be continuous data because we would have populations in between here that would continue to grow.